Lesson 22.2, Task 2. Create histograms. A histogram is a statistical graph used to display data grouped into intervals of equal width. Histograms are useful for displaying the shape of the distribution of data. To create a histogram, first group the data values into intervals of equal width. Use a frequency table to help you organize the data into these intervals before constructing the histogram. Then display the intervals on the x-axis and show the frequency on the y-axis. Bars are used to show the number of data values that fall into each of the intervals. Alright, so Crazy Claw Cactus Shop sells a variety of domestic indoor cacti. Alright, so it gives you a table here. It has the heights in inches of 50 cacti. So these are the heights in inches. It says create a frequency table. The data values range from 1 to 39, so use an interval width of 5 or 10. All right, so it says why do you need to create a frequency table first? So you need to establish the intervals and count the frequencies for each interval before you can create the histogram. All right, so you see this goes from 0 to 4, 5 to 9, 10 to 14, 15 to 19. So these are equal in width. So from 0 to 4, 5 to 9, each of these are 4 inches, a difference of 4 inches. So these have to be equal. And then your frequency comes from how many times it occurs. So this tells us that 11 cacti plants are between 0 and 4 inches tall. This tells us that 7 cacti plants are between 5 and 9 inches tall, and so on and so forth. So if you add up all the frequencies, that should give you a total of 50 because we started with 50 cacti plants. All right, then you can make your histogram table based on your data there. So you have 0 to 4, 5 to 9, so this is cacti heights in inches. So this goes by your intervals, and this is your frequency, how many times it occurs. And again, this comes straight from the table. So you can see that frequency of 11. So 11 cacti are between 0 and 4 inches tall. So from 0 to 4, there is 11, or the bar goes up to 11 on the frequency. So that's how you construct the histogram. So it says make sure the sum of the frequencies is 50. Okay, so to do that, you would just total these numbers here and make sure they add up to be 50. Why should the sum of the frequencies be 50? The sum of the frequencies should always be 50. There are 50 values in the data set. The greatest height is 50 inches. So again, there are 50 cacti plants that they measured the heights of. So that means there's 50 values in the data set. All right, that's all for task 2. If you have any questions, let me know. Lesson 22.2, task 3. Use box plots to describe data. A box plot is another statistical graph that shows how values in a data set are distributed. 5 key values that summarize the data set are displayed in a box plot. All right, so this is an example of a box plot, and this shows you what all the different parts are. It's important to know what these are so that you could draw one on your own. All right, so the minimum value here is the left whisker. You have your first quartile, which is Q1, okay? So, and that's the median of the lower half. So if you find the median of the lower half of your values of your data set, that would be Q1. Your actual median of all the data values is here. And then this is Q3, or your third quartile, which is the median of the upper half of your data set. And then if you have a maximum value that's outside of there, then this would be your other whisker. So this is considered a box plot. Make sure you know what all the different parts are. All right, the calendar shows the daily high temperature in Fahrenheit on each of the first 21 days in January at a weather station. Create a box plot that models these data. All right, so we're going to use these numbers here to make a box plot similar to this. All right, so it says determine the 5 key values for the data. So what are the key values? We need the minimum, Q1, we need the median, we need Q3, and remember the median is Q2. So Q1, Q2, and Q3 makes the box, and then your minimum and your maximum make the whiskers. So that's what we need. All right, so you can easily identify the minimum and maximum directly from the list. So if you look at the temperatures here, you can see that the minimum is 15 and the maximum is 54. When making a box plot by hand, this is important to make sure these values are in order from least to greatest. Okay? So arrange the numbers from least to greatest. So these are the temperatures from the calendar. All right, so it says there are 21 data values. So the median, Q2, is the 11th number in the list. All right, so we just have to find the middle number to find the median. Okay, if you look at the middle number, that is 30. All right, so it says, is 30 part of the upper or lower half of the data? Select the correct statement. The median is part of the lower half of the data because 30 is closer to the minimum value than the maximum. Because 30 is the middle value, it is not part of the upper half or the lower half. That is true. Because 30 is the median of the two middle values, the data value 30 is included in the upper half, so that one is not true. All right, so the median, remember, is the middle number when they're listed from least to greatest. So there are 10 data values on either side of the median. 30 is the median. So it says identify the values of the first quartile, Q1, and the third quartile. All right, so remember it said above that the median is the median of the lower half of data. So whatever your lower half of data is. So what we would do is look at the numbers from 15 to 30. So this lower half, to find the median of that, we'd find the middle two numbers and add those and divide by 2. So that's what they did. So they took 17 plus 20 divided by 2 is 18.5. Why is Q1 the mean of 17 and 20? So why did they take the average of these two numbers? Because there's 10 values on the left of the median, which means you have to find the average of the middle two. All right, so see what our choices are. The lower half of the data set includes some numbers in the teens and some in the 20s. 17 is the largest of the teens and 20 is the smallest of the 20s. That doesn't sound correct. Because there are 10 values in the lower half, the value of Q1 is the mean of the 5th and 6th value. The 5th and 6th is the middle two of the 10 values on the left. In that order group, 17 and 20. So that one makes the most sense. All right, the third quartile, you're going to do the same thing. You're going to find the mean of the upper half of the data set. So why is Q3 the mean of 40 and 45? Well, for the same reason that Q1 was the mean of the lower half of the data set. So it says because there are 10 values in the upper half, the value of Q3 is the mean of the 5th and 6th value in that ordered group. So that one would be true. All right, and then once you have your 5 data points, you will draw your graph. So you take the minimum value here. The minimum was 15. The maximum is 54. So you can see the minimum 15, the maximum is 54, and then we had the median, and then this is Q1 and Q3, which we just found. So the median again was 30. So you can see the median here is at 30, and then your Q1 and Q3 determine where the box goes. So you just draw the box with the median it doesn't necessarily be in the middle. In this case, it looks like it kind of is. And then you have your minimum and your maximum become the whiskers. All right, that's all for drawing a box plot. If you have any questions, let me know.